Here we've got the people who like Venn diagrams. Here we've got the people who draw circles around their notes. And people who put their coffee cups down on their work. And right here in the intersect of all three circles, you'll find me. I'd be interested to know where you find yourself as a student. Do you get good grades? Do you have social life? Do you get enough sleep? Or are you some combination of these sets? My name is Miss Danielson, and today we're looking at Venn diagrams and set theory. Let's get into it. There's quite a bit more to set theory than just drawing Venn diagrams, so let's get into the notation, and you're going to want to take notes because there's quite a bit to remember. First of all, this first symbol here represents the universal set. The universal set describes the only members to be considered in any given question. So for example, if I say that the universal set are the students of Queen's College, I might be talking about the grades that students earn on the math exam. I may talk about the subsets of girls' results and boys' results, but you have to keep in mind that I'm not talking about all of the boys and girls in the universe. I'm just talking about the boys and girls at Queen's College. A 0 with a line through it like this represents the null set, or an empty set. This is a set which has no members. So for example, a set of vegans who eat meat would be a null set, because vegans by definition don't eat meat. Sets are a collection of elements, and we define them using these curly brackets, and they must be curly brackets, and list the elements. Or we could use curly brackets and define the rule that the elements of that set must follow. We could also show a null set by using these curly brackets and not putting anything inside them. This symbol here, which looks kind of like a C with a line through it, tells us that this first value is an element of this capital letter. That's the set. It shows set membership. So for example here, where we say that set A is 3, 9, and 14, we could state that 3 is an element of A. 3 is a member of A. Similarly, we could draw that same symbol with a line crossed through it, and that simply means that it's not an element, it's not a member. So here X is not a member of set A. And as our example over here, again, we see that A is the set 3, 9, and 14, and 1 is not in that set of values. 1 is not a member of set A. Another way we could talk about what's in A and what's not in A is using A with this little line up at the top. This is called not A. If set A is defined by some given rule, then not A is the set of all of the other elements inside the universe which are excluded from that rule. So for example, if A were all the positive numbers, not A would be all the negative numbers, including 0, because 0 is not a positive number, and not A must include everything that's not a positive number. Next, we've got the subset. It looks kind of like a C, but be careful. It's not part of a circle. It's more like a U. The top and the bottom of this symbol are straight lines. They don't curve back together here. A subset is a set which fits completely inside another. So for example, multiples of 8 are a subset of even numbers. All of the multiples of 8 are also even. There are no multiples of 8 which are not even. Similarly, if we draw that same symbol of the subset, but we draw a line through it, that simply means that it's not a subset, which means the set may have one or more elements which do not lie within the other set. For example, if A is a set of odd numbers and B is a set of prime numbers, B would not be a subset of A. We could not fit all of the prime numbers within the set of odd numbers because 2 is a prime number and it's even, not odd. The next symbol is the union symbol. Again, this just looks like a U, but it doesn't have any little stick on the side of it. The union of a set is a combined set of all members of one or both sets. The same symbol upside down is the intersect. The intersect of two sets are only the members which are in both sets at the same time. That's the overlap bit between the two circles in the Venn diagram. Finally, N with some set name is the number of members or elements in a set. This is a very common mistake to make on an exam. If they ask you to list the members of set A, you must use curly brackets and list them all. If they ask you for n bracket A, they're just asking you to count how many members there are in set A and give that number, and don't put that number in curly brackets. Make sure you've copied down all this notation before we get into an example to see how it gets put into use. Now you're going to want to copy this example as well as the notes we make about it. Here we've got two sets which are defined, and we use capital letters to name these sets. We define the sets or list the values within the set using our curly brackets. So here set A is the set of prime numbers between 10 and 16. And set B are the multiples of 3 between 10 and 16. Notice I didn't define the universal set. I could have done this separately. I could have said that the universe were the values between 10 and 16, and then I could just say that set A were prime numbers and set B were the multiples of 3. For part A of this question, we're asked to work out the union between A and B. The union includes all members of one or the other or both sets. Think of this as A and B uniting to form a team. Here I've got a list of all of the members of set A in red. That's just 11 and 13, the only two prime numbers between 10 and 16. And all of the members in set B, that's just 12 and 15, the only multiples of 3 between 10 and 16. In this case, there was no overlap. So I've just listed all of the members of A and B together to form that union, to form that team. Part B asks me about that intersect. The intersect includes only the members of both sets at the same time. Now in this case, as we've just seen, there are no prime numbers, which are also multiples of 3 between 10 and 16. So what should we put for this answer? Remember, it's a null set, so we could put either one of these symbols. Either we can put those curly brackets with nothing in between them, or we could put a 0 with a line through it, which represents the null set or the empty set. Is it true that 11, what's this symbol? B. Is 11 an element of set B? If that's true, looking at the definition of set B, 11 would be a multiple of 3. Is 11 a multiple of 3? No, it's not. Explain your answer and make sure you explain your answer fully in words. 11 is not a multiple of 3, so it's not a member of set B. It's not enough just to say because it's not listed. Make sure you copy that down along with all the notes we made about this question, and let's go on to another example. Here we've got a universal set defined as Angela's furniture. Set A are chairs, and set B are kitchen furniture. Remember that we're only talking about Angela's furniture. So when we're asked to describe A intersect B, we're looking for elements within set A, so Angela's chairs, and at the same time within set B, so Angela's kitchen furniture. So what elements are in both sets at the same time, taking into account as well the universe? This subset, A intersect B, would be Angela's kitchen chairs. For question B, we have two more sets defined. P is defined just by listing the members of the set, so 2, 4, 6, and 8. And Q is defined by a description of what's inside the set. Q are the odd numbers less than 10. So let's list the members of the set P union Q. Remember, the union includes all of the members of one set or the other set or both sets. This is the unified team of everything in Q and everything in P. So I would list all of the elements of P, and I would list all of the elements of Q. So P, I've got 2, 4, 6, 8 in red, and Q, I've got 1, 3, 5, 7, and 9. Is it true that P intersect Q is this circle with a line through it? What does that mean again? Yes, it is true. The intersect is a null set again. There are no elements in the intersect of these two sets. But to explain our answer, our explanation must include the definition of the sets P and Q. Q is a set of odd numbers, and P only contains even numbers, so the sets will have no values in common. You could also say that there are no values in set P that are odd. Now that we've covered the notation, let's move on to the Venn diagrams. Venn diagrams are a graphical way to show an element's membership of one or more sets. Some of you may be familiar with this particular Venn diagram, which depicts the unfortunate predicament of Schrodinger's cat. Can anybody tell me down in the comments section what the story is about Schrodinger and his cat? Maybe we should start with the basics. Venn diagrams involve a rectangle, which represents the universal set, and within that universe, we'll have some subsets. Subset A, for example, and subset B. Now, they won't always be drawn in this same way, but in this particular case, subset A intersects with subset B, right here in the middle. Now, if I start shading my Venn diagram, I'll be representing different subsets of the universe. Here, for example, I've shaded everything that's either in A or in B, or both. Members of one set or the other form the union. So this is A union B that I've shaded. Similarly, I could look at sets A and B, which intersect in the same way. If I'm just looking at the intersect here, this represents the members inside both sets at the same time. So these are the members of set A and set B. If I just shade this part of A, so I'm not shading the bit in the intersect, we're getting a little bit more advanced here. These are the elements of A, which are not in set B. So here we set up a rule with our set notation saying that the shaded section of our Venn diagram are all of the members in set A, but at the same time, they are not in set B. So the overlap of A and not B. Here I've got all of the elements of A, as well as this whole region outside of B. That would be the subset A union not B, because it's anything that's inside A or anything that's not in B. Here's a GCSE exam question to see how this could actually be asked on an exam. Here we've got a Venn diagram where B is completely inside of A. What set notation can we show for a set that's fully inside another one? B is fully inside set A, so we could say that B is a subset of A. In this next Venn diagram, I've got sets A and B, which don't overlap at all. What set notation should I use to explain that these sets do not overlap? They have no intersect, so no elements in common. We could say that the intersect of these two sets is a null set. There's nothing there. Next, let's try an example where we're asked to complete a Venn diagram. Notice they've given us a template for our Venn diagram here, which has got two sets within the universe, and these sets seem to overlap. They've also given us some information about the universe and these sets, but notice this n in front of the universe. N bracket A refers to the number of elements within set A. So don't get confused with listing the elements. When we're told that NA is equal to 22, that doesn't mean that 22 is a number in set A. That means that set A has 22 elements within it. These could be 22 people, 22 cars, 22 stores, 22 anything. There's 22 members of set A. And the N in front of the universe tells us that there are 37 members of the universe. Altogether, there are 37 elements that we should be considering in this question. So if there's 37 elements in the universe, there's 22 elements in A, and A intersect B contains 12 elements, and A union B contains 30 elements. We need to complete this Venn diagram to show the total number of elements in each part of the Venn diagram. Now be very careful. Although the first thing we're told here is that there's 37 elements in the universe, don't just put 37 down here. These 37 elements must be distributed throughout the Venn diagram in their correct places. We're told that set A has 22 elements, but don't just put the 22 here. Some of those belong in here. When we're completing a Venn diagram, we should always try to start at the intersect. And we're told that in the intersect of A and B, there are 12 elements. So I'll start there. Now we can go back to the number of elements there are in A. If there are 22 elements in A, and 12 of them are already in the intersect, 22 minus 12 means that we must have 10 elements in this part of A, which is not in the intersect of A and B. To find out how many elements go in here, we're not told how many elements there are in B. However, we are told that in the union of A and B, there are 30 elements altogether. If there's 10 here and 12 there, that's 22. How much must be here? 30 minus those 22, that leaves me with 8. So there must be 8 elements in this part of B, but how many elements are there in B altogether? Set B has 8 plus 12, that's 20 elements or 20 members. Finally, don't forget about this spot. Very often that's where you'll lose the marks. You've completed the Venn diagram within sets A and B, but you've forgotten about the elements which are not in set A or B. So out here, remember that there are 37 elements in the entire question, and so far we've got 30 elements in the union of A and B. So 37 minus 30, there must be 7 elements in the universe which are not in the union of A and B. So now that you've seen a good variety of different types of Venn diagram and set theory questions, let's go on to some practice now. For question 1, I need you to remember your set notation to remember what A and this symbol B means. And more specifically, what does this little line mean outside? This is A intersect B, and that little line means not A intersect B. You need to shade the subset described by the notation that I've given you here. So in this diagram, shade in not A intersect B. For this next diagram, be careful, because here we've got not A, and outside of that, I've got another not. What's not A? Not A intersect not B. Think of how you're going to shade that in. Or here we've got B union C with the not outside, so not B union C, or not A union C. Finally, for question 2, we've got some information about the universe and some different sets within that universe. So I've got a template here for you for a universe with 3 intersecting sets. And for part A, you need to complete this Venn diagram to show the members of each set. Set A shows the factors of 18, but as the universe only shows whole numbers up to, but not including 20, consider what those values might be. For set B, it's the factors of 14. For set C, it's the prime numbers. Now let me help you out here. Remember, we always start by completing a Venn diagram with what's in the intersect. Well, in this case, we have 3 intersecting sets, and there's only one value that belongs in all 3 of those sets. What value is a factor of 18, a factor of 14, and also a prime number? I'm hoping you're not thinking 1 because 1 is not prime. 1 only has 1 factor. Prime numbers have just 2 factors. 2 is a factor of 18 and 14, and it's a prime number. So that gives you a good head start for part A. But when you go on to question B, you need to complete this Venn diagram to show the number of elements in each set. So I don't want you to list the numbers that are in set A. I want you to count how many members there are in set A, how many members are in set B, and how many members are in set C, and in their intersects. Again, to help you out here, how many members are in the intersect of A, B, and C? Have a look at the Venn diagram I started for you. There's only one value in the intersect of A, B, and C. So over here, I'm not going to put what that value is. I put how many values there are. There's one value there. Now, hopefully that's given you a good head start. Go ahead and hit pause now so you can copy that notation and those diagrams down. and give it a go and hit play when you're ready to take it up. I hope you've had a chance to hit pause, because here come your answers. For question 1, first I shaded in everything except the intersect of AB, because this is not the intersect of AB. For the second one, not A would be A, so we're shading the intersect of A and not B. If I shaded all of A, I would have shaded this part as well. But it has to be in A, but at the same time, and not in B. So outside of B, not including the intersect. In this third diagram, I've shaded everything except for the union of B and C. You see the union of B and C is here in white. I've shaded everything but that. And in this fourth diagram, not A, union C, as you see, I shaded everything that's not inside A, as well as this bit here because it's inside C. For question 2, completing this Venn diagram with its members, let's start with the intersect of A and B. Both 18 and 14 have a factor of 1, but 14 has also got factors 14 and 7. Now 7 is a prime factor, which is why it's also in set C. 14 is not a prime number, nor is it a factor of 18. In set A, we've got the factors 18, 9, and 6, which are neither prime nor factors of 14. 3 is prime, however. 2 is prime and a factor of 14, and 1 is also a factor of 14. So those are all of my factors of 18. And finally, set C, which was the prime numbers. Here I've got 2, 3. The next prime number I'm thinking of is 5, then 7, then 11, 13, 17, and 19. So I've got all of my prime numbers up to, but not including 20. And that's it. What's missing, however? I filled in the elements of set A, I filled in the elements of set B, I filled in the elements of set C, but don't forget about the universe. The universe contains all of the positive numbers less than 20. Have you done that already? If not, hit pause now and make sure you do that before I put it up. The values in the universe which are not in the union of sets A, B, and C are 4, 8, 10, 12, 15, and 16. Now, given that Venn diagram with all of the members of all of the sets, we should easily be able to count how many members there are in each set and subset and just put the number of elements in the correct places in the second Venn diagram. So starting with the intersects, of course, we knew that there was one value in the intersect of A, B, and C, that was 2. There was one value that was in the intersect of A and B, but not in C, that was the number 1. There was one value in the intersect of A and C, but not in B, that was the number 3. And there was one value in the intersect of B and C, but not in A, and that was the 7. Then in set A, in total, there were 6 members. There are 6 factors of 18, but 3 of those factors are not factors of 14 and are not prime numbers. Those were the numbers 6, 18, and 9. In set B, there are 4 values altogether, but only one of them was not a factor of 18 or a prime number, and that was the number 14. And in set C, there were 8 values altogether, but only 5 of them were not factors of 14 or factors of 18. Those 5 numbers are listed here. And don't forget as well, how many values are there in the universe but not in the union of A, B, and C? I see 6 here. So let's just double check that. If the universe represents all positive whole numbers less than 20, so not including 20, how many values should there be in the universe altogether? 1 to 19, that's 19, right? Checking that, that's 6 plus 3 is 9, 10, 11, 12, 13, 14, 19. 19 values altogether. Well done. So how did you do? Hopefully, you're starting to get the hang of it. It always seems easier in the beginning, and then it becomes really quite complicated. So please let me know down in the comments section if there's anything that's still a little bit unclear. Maybe I can give you a little bit of extra support on something. Otherwise, well done. Great start. Keep up the good work, keep practicing, and I'll see you soon.